slowly start. So good afternoon, everyone. Welcome to this edition of the NITheCS Colloquium. This afternoon, it's a real pleasure to have Professor Judy van Biljon with us. And the real pleasure stems from the fact that, that Judy is one of the new associates of NITheCS. Yeah, so she's a new entry in the new NITheCS family, and and this is exactly what we want to achieve. We want the new members of NITheCS to introduce themselves to the new NITheCS community, and of course to whoever wants to join us and attend this this colloquia. So Judy has a PhD in computer science from UNISA, and at the moment she's an NRF research, NRF chair in information and communication for development, ICT 4D, in the School of Computing of the University of South Africa at UNISA. Yeah. She has contributed a lot to academic knowledge by publishing mainly on human-computer interaction and design for marginalized group, technology adoption, and sustainability in digital learning for resource-constrained environment. She's currently serves also as associate editor of the journal Information Technology for Development, and is the senior editor of the Electronic Journal of Information Systems in Developing Countries. Yeah. So Judy, what you do is really fits 100% in what NITheCS want to achieve, because you know that NITheCS is a South African institution, but based on the African country. So your approach to artificial intelligence is of great interest to the whole community. So Judy, if you would like to start sharing the screen, you're most than welcome to start your presentation. And while you do so, I will remind the participants to please make use of the Q&A facility that you should see at the bottom right of your Zoom screen. And Professor Sinaisky and myself will keep an eye on the questions and pose them to Professor van Biljon after her talk. So Judy, thank you very much for being with us, and we are really looking forward to listen to your talk.
Thank you, Francesca, for the kind introduction, and for everybody in the audience for joining me on this road trip to discover machine learning for the developing world. Just tell me, are you seeing the right screen, the one with the one picture, or are you seeing two slides?
No. We see the right screen with a wonderful image. Yeah. Thank
you. So many of you in the audience today know machine learning, and you know the route to machine learning, you know the achievable goals, the obstacles. And then the other people here, many of whom I also invited, know about global development and the route to pursue those goals. So what I would like us to consider today is a starting point towards machine learning for developing countries. The first, and I'm going to just share a few basic constructs about the two concepts, machine learning, developing countries, and then I'm going to discuss a few challenges, opportunities, and then I'm going to present a roadmap. And that's where I would like you to join in, so to critique that roadmap. So concerning developing countries, that is a country with a less developed industrial base and a low human development index relative to other countries. This is based on the income groups, and often the countries are divided into 4 groups, and even those groups can be grouped together. So South Africa is often classified as a low middle income country. Another angle is to look at markets and economic growth. another angle is to look at geography, because landlocked countries have specific challenges, as do island nations. Finally, some choose to be considered as developing countries like Hong Kong and Singapore, which possibly we didn't, I wouldn't actually suspect that. So when we look at the geographic distribution of developed countries, we see that most advanced economies lie in the global north, except for Australia and New Zealand. The in-transition countries are often the former USSR, together with Chile. South Africa is considered less developed, and then there are the least developed. Now, I have to add that this map is flexible and it's dynamic and possibly contested. So it's just meant as some indication of what we mean when we talk about developing countries. Now, apart from this economic approach to development, or let me rather say the financial approach, the economist Amartya Sen asked this question: what is the relation between our collective economic wealth and our individual ability to live as we would like? This question was asked against the background of the fact that the world has enormous wealth, and yet many people are still living in what can almost be considered economic slavery. They could work as hard as they like, but they will probably never escape their situation of intense poverty. And he said, maybe it is not a fact of a rising tide will lift all boats, as the economists like to say, but rather we should consider development as the process of expanding human freedom and the enhancement of these freedoms, specifically the capability to make choices towards living lives that people have reason to value. And clearly, that is a subjective thing. The one person may want 5 goats and be happy to have 5 goats, and that is the life they value, whereas the other one would continually strive to buy more goats and extend, and that is the value, that is what they value. But at least that people have the capability to make good choices. Fortunately, whatever angle you consider on development, most people agree that the Sustainable Development Goals, these are United Nations goals, supposed to be met by 2030. Most people agree that these are good ideals, although they are maybe idealistic and not well defined. But for most development programs, this is what's being considered. Then a quick look at machine learning. Many definitions to consider, so I would just keep with machine learning refers to the study of computer algorithms that improve automatically through experience and by the use of data. Now, ML uses algorithms and, importantly, statistical models to teach a computer system how to perform a variety of tasks based on observed data. And then it can perform these tasks on unobserved data without any human interaction. That is the real goal. Now, I would just like us to step back and consider the difference between human-computer interaction for development and human-computer interaction, because I think that difference resonates with the difference between ML4D and ML. Considering HEI for development, the focus is on practicality, pragmatism, whereas in HEI, the focus is on novelty. And in HEI, a person can come up with a prototype and not consider the cost benefit. Whereas in HEI4D, that is critical. Furthermore, the route to scale. In HEI4D, there's an expectation that this research should be able to scale. Therefore, the research concerns government policies, and the aim is always to involve multilateral organizations like the United Nations or the World Bank. So given this, the implementation details are pertinent. Then finally, this is in situ research. The context is key. So prototyping, experimentation, and evaluation, that needs to happen in the context. So in order to be able to distinguish projects, it is useful to look at their key properties. The first one is that the application and data are geographically constrained to developing countries. So this is not the kind of research that somebody sitting in New York can do and come up with a solution. The problems concern a critical development area for the region of interest. This is often linked to the SDGs, but clearly that problem must be relevant for the context. Then it must contain a substantial ML element. Given the hype of ML, I think you've all seen papers where there's a bit of ML in the title and a bit in the abstract, but when it gets to the research design, there's actually very little contribution. Finally, the problems necessitate solutions that differ from existing or plausible solutions in developed regions. So I would like us to look at a few use cases. Sorry, let me just go back. Well, there are more, but health is an important use case. Institutional, economics and finance, social, engineering and environment. Looking at health, in Brazil, they used machine learning techniques for the interpretation of classification results, those 4 biomarkers, and that allowed GPs to diagnose kidney disease with high accuracy as compared with experienced nephrologists. Now, this is important because there aren't that many nephrologists in the area. And that's why I consider this to be a valid ML4D application. Rwanda, that's a very common example where they have this aerial robot equipped with automated logistics systems and cutting-edge computer vision technologies for delivering blood and drugs. When one sees this, I think people in developing countries immediately say, well, the first thing is to make sure that there is a clinic and that there are drugs to deliver. So this is all context dependent, and basic amenities need to be in place for this to work. Then in South Africa, there's a study to promote smart policing in under-resourced settings. They used feed-forward neural networks and recurrent neural networks to predict the number of calls made to police stations, and then use that to model what is required. In East Africa, this was a cross-border study. Well, we can agree that understanding spatio-temporal resource preferences is paramount in the design of policies for sustainable development. So they use a probabilistic approach and the consideration of generative models to simulate behavior under new circumstances, such as changes in resource availability, access policies, or climate. Then another example is in Kenya, where they used predictive modeling for academic performance. Another one in Kenya, where they used mobile data to test anthropological and economic theories regarding human migration patterns out of Kibera, that is a slum area, by inferring the places of work and tribal affiliations. Another one in Africa is, that's also a cross-border study, where they use feed-forward neural networks for automatic identification of African languages, which comprises a challenging task due to the low resource data for such languages. This work then also uses text-to-speech and automated speech recognition to enable such these populations to access resources on the internet. Finally, engineering and environment. Nigeria is doing research on online voltage collapse prediction model and voltage stability index based on multi-layer feed-forward neural network. And South Africa, there's another study on comparing techniques for clustering metered residential energy consumption data to construct representative daily load profiles. So yeah, there are many more, but I just picked a number to show that these people have the integral ML component and they address problems in their country. Now the obstacles. Many of well-known is, I guess, the large data set required for ML and labeling requirements. There's also the computational capacity in terms of infrastructure and skills. And then there is internet accessibility. Now, before we continue, I'd just like us to kind of stand back and say, what are we dealing with here? ML outcomes are aligned to produce a structured set of decisions or estimations. And it discriminates. Yes, discrimination in this context is the recognition and understanding of the differences between items. And that's fundamental to ML operations. And the challenging thing is identifying and assessing the social implications of ML systems. And I give you one example here of using learning analytics to classify at-risk students. And quote, the wrongful allocation of a student to an at-risk group, that's the false positive, can thus carry with it the additional burden of stereotype threat, reaffirming racial inequalities and stereotypes, as well as activating the Gollum effect. The risks associated with a false negative are far more benign. Now, I would like you to look at that, think about that. I think we may not all agree on what is more benign and less benign. I mean, the implications of either of those is very context dependent, and it may cause the program to be stopped. And what would the cost of that be? So these are really deep considerations. And and this speaks to the hype-fear debate, the hype versus the reality of what is possible and responsible. And I see a lot of academic opportunism in my mind, of all the biases and well, certainly we have to be aware of the biases and we have to work with those. But I think a person also requires a deep understanding of the subject and machine learning before you make superficial comments on what the biases mean and what the alternatives are. So transparency and control, the social contract with data, the data value chain, which, well, the aim is to have benefit for all. Now, the understanding of the governance roles and responsibilities associated with ML. I happen to know about people working in the UK, and there they said roughly 17 institutions trying to regulate this in the finance industry. And you can think that there are turf wars, and it needs to be done, but who should do it and who should take responsibility for that? So it is certainly an obstacle. Then finally, publishing interdisciplinary research in high impact journals is not easy. And ML4D is certainly interdisciplinary. Well, after all of this, are you still considering the topic? I hope you haven't all left. Is it a worthwhile topic? I happen to see it as a wave, possibly a tsunami. And researchers can either look at this and think, how can I find a way to ride the wave? Or one can possibly lie down and hope that it will pass soon. On the positive side, there's a lot of funding going this way, World Bank, United Nations, etc., and collaboration opportunities. As developing country researchers, the people have a context advantage because currently the data is very biased, and in many contexts, many areas, they need to get more developing country data, and the best way, the easiest way is possibly to work with people on the ground. Then there's a saying, a very contested saying, I should add, if you are not a communist at the age of 20, you haven't got a heart. If you are still a communist at the age of 30, you haven't got a brain. And similarly, I mean, that may be said in jest, but similarly, I think students really have a heart for developing country research. And there's untapped potential that we should take note of. A person working on a problem to improve the lives of impoverished people would possibly be much more motivated than a person who is doing this research to please his supervisor. Both cases, there's a qualification at stake, but I should add, considering all the other complications of doing this research, it is something to consider. And at what stage this should be done, maybe as part of a PhD, maybe as part of a postdoc. Those are things to think about. But certainly it has real world, real difference allure. Then to kind of ground this literature discussion, I looked at Scopus, the search string machine learning and developing countries. For the dates 2010 to 2021, as on 12 July, looking only at article and conference papers in English, I found 387 documents. Comparing the documents counts for the top 10 countries, we see that India is tops. Then the United States, not a developing country, then China, then Bangladesh, Pakistan, United Kingdom, Saudi Arabia, and then South Africa with more than 10 papers. So I was really happy to see us in that lineup. More results from the literature review. If you look on the left, you can see the year and the documents. And we can see how those picked up, starting with 5 up to 140 in 2020. That's the tsunami I was referring to. The documents by subject area, most of those computer science, some engineering, some mathematics, critical data science fields, and then there was some lesser in the other fields listed there. This is now by subject area. Then I thought, let us look at sub-Saharan Africa. And there I need to thank Malasela and Hulusani, who helped me to extract the documents and analyze them. When we look at sub-Saharan Africa, only 8.7% of those papers came from this area. And where do they lie? There was some in Senegal, Ghana, 5 in Nigeria, 5 in Ethiopia, 3 in Kenya, 1 in Tanzania, some in Uganda, Rwanda, the DRC, and then South Africa with 7, and some of those were with kind of across borders, more than one country. So I thought that was quite an interesting distribution. Then looking at the application areas, now they had to analyze this by looking at what was the purpose, what was the contribution, and then one is able to see where is this research actually lying. And it's clear that health, most of the studies is still being done in health. Engineering, close second, the environment, and then lesser studies, transport, agriculture, education, and economic. Now, towards a roadmap, the good authors, Ortega, Helen, Neil, and Dabrowski presented this roadmap where they say, well, the first thing is to consider the context. Then, if you want to think about the ML4D roadmap, you should think about improving data reliability. You should think about providing direct solutions and deploying systems. And thirdly, you think about informed policy and decision-making. And related to each of those goals, what I call goals for the roadmap, there are novel methods concerning data. That would be learning with small data, learning from multiple messy data sets, intelligent data acquisition. Concerning the solutions, it would be transfer learning for low resource languages, learning with limited memory and computation, and intelligent compression algorithms. And for the policy, that would be decision support systems. So I looked at that and I thought about what I've seen in the papers, and I thought, let us see how this can be adopted maybe for the African context. And the first thing I would add is data availability. In my mind, you cannot have considered data reliability before you have the data, which was possibly not a problem in other contexts, but we have to start with where is the data? What data do we have? Then the fourth construct I had was about the policies. Now, the policy, I believe, should go across all those. In a well-governed society with proactive governance, one should actually start with the policy before doing all the other things and at the end deciding, oops, now we need a policy to govern that. And then you have 17 or more institutions fighting to write the policy. And that is not where one would ideally land. The other thing is skills development. None of this is possible without the appropriate skills. And in developing countries, that is something that we should consider for each of these phases. The methodological considerations, there I kept those the same, and hopefully you can add some. And then the thing that covers all, includes all, is the context. So this is the model that I would suggest and the model upon which I would like to get your input. Now, let me just finish by saying that I have references like a good academic, and I also would like to thank you for your presence and acknowledge people that made on different levels and different contributions towards this presentation. I thank you.
Yeah, Judy, thank you so much for the very interesting talk and for giving us this really nice overview of the multiple aspects of machine learning for the developing world. Now, thank you so much.